Hello everyone and welcome back to section 6.4. We're going to be talking about rectangles this section. Last week we used the properties of parallelograms and determined whether quadrilaterals were parallelograms. This week we're going to recognize and apply the properties of rectangles. We're also going to determine whether parallelograms are rectangles. So the only new vocabulary this chapter is a rectangle. Recall from 2 weeks ago, a property of parallelograms was that a parallelogram with one right angle has four right angles. Anytime a parallelogram has four right angles, it's a special case of a parallelogram called a rectangle. In parallelogram ABCD, segment AB is still congruent to segment CD, and segment AD is still congruent to segment BC. And the two opposite sides are still parallel to one another, like so. Since a rectangle is a parallelogram, all the properties of parallelograms apply to rectangles as well. In our first theorem for this section, it states that if a parallelogram is a rectangle, then its diagonals are congruent. So in rectangle JKLM, the segments JL and segments KM are congruent to one another. Because the diagonals of a parallelogram bisect each other and the diagonals of a rectangle are congruent, the bisected segments are all congruent. So if we had a midpoint P, then segment JP would be congruent to segment KP, which would be congruent to segment LP, and that would be congruent to segment MP. For real world example 1, we're given that a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK equals 12 feet and LN equals 6.5 feet, find the value of KM. It's our green segment here. Since JKLM is a rectangle, it is a parallelogram. The diagonals of a parallelogram bisect each other. So LN equals JN. So we know that JN plus LN equals JL by segment addition. Since JN equals LN, we can substitute LN for JN, giving us LN plus LN equals JL. Combining like terms gives us 2LN equals JL. Substituting in the value of LN as 6.5, we get 2 times 6.5 equals JL. And then finally we get 13 equals JL. The problem asks for the measure of KM though. So since JL equals 13, what is the measure of KM? Since the diagonals of a rectangle are congruent, the measures are equal, and so KM has a measure of 13 feet. In the next example, quadrilateral EFGH is a rectangle. If GH equals 6 feet and FH equals 15 feet, find the measure of GJ. Since EFGH is a rectangle, what do we know about segment FH and segment GE? Because the diagonals of a rectangle are congruent, segment FH is congruent to segment GE. Now, find the value of GJ. In example 2, quadrilateral RSTU is a rectangle. If the measure of angle RTU equals 8x plus 4, and the measure of angle SUR equals 3x minus 2, find x. Since RSTU is a rectangle, what do we know about the measure of angle TUR? Highlighted in green. Since RSTU is a rectangle, we know it has 4 right angles. So the measure of angle TUR equals 90 degrees. We also know the diagonals of a rectangle bisect each other and are congruent. So segment PT is congruent to segment PU. Since segment PT is congruent to segment PU, what type of triangle is triangle PTU? Triangle PTU is an isosceles triangle because the two sides, segment PT and segment PU, are congruent. Since triangle PTU is an isosceles triangle, what pair of angles is congruent? The angles opposite the congruent sides are the angles that are congruent. In this triangle, it's angle SUT congruent to angle RTU. Now that we have a pair of congruent angles, it's time to work towards the solution. The measure of angle SUT plus the measure of angle SUR equals 90 degrees. Since angles RTU and SUT are congruent, their measures are equal. We substitute the measure of angle RTU for the measure of angle SUT. We then substitute in our expressions and get 8x plus 4 plus 3x minus 2 equals 90. Combining like terms gives us 11x plus 2 equals 90. Subtracting 2 from both sides gives us 11x equals 88. Dividing through by 11 gives us x equals 8. In our final example of the day, we're given that quadrilateral EFGH is a rectangle. If the measure of angle FGE equals 6x minus 5, and the measure of angle HFE equals 4x minus 5, find the value of x. Which angle is congruent to angle HFE by the isosceles triangle theorem? Angle GEF is congruent to angle HFE by the isosceles triangle theorem. Angle GEF is congruent to angle HGE by what theorem or postulate? Angle HGE and angle GEF are congruent because segments GH and FE are parallel and therefore form alternate interior angles. Then for the last question, what is the value of x? And that concludes the video for today.